Now we see the characteristics of a wave motion. In the last we seen what the properties or a phenomenon or a behavior of an waves. Those are called as of a reflection, refraction, absorption, interference, diffraction, polarization. Right? Now we have to be seen the characteristics of a wave motion. In that we have to be seen first one is the wave length. What is wavelength? In the direction of a propagation we already discussed what is the wavelength. That is there is a distance between the two crest and the two trough. That is the one characteristics of an wave motion. And now here there is it is only the energy of an disturbance that moves forward without any mass transfer. What happens? What is the characteristics of this wave? It is only the energy of an disturbance that moves. What happens? Only the energy will be energy of the disturbance will be moves forward without transferring any mass. Only the energy can be travels, that not the mass. Here there is no transfer of an mass will be taken place. Only the disturbance of an energy will be moves forward. That is the one characteristic of an wave. And that is in an elastic medium what happens? The frequency and the amplitude of a oscillation of each particle is the same. What happens? Here we see here there is a direction of a propagation. We call this is the one oscillation, and this is the in the how much of a time at a per time there will be one cycle completed, that will be called as the frequency f, that will be denoted by the hertz. Is it right? That is here there is an amplitude, there is the peak distance between the plane of an wave or an constant direction or a base of an wave, what we have to be called in the diagrams. That is the distance between the peak of an wave, or that is called as of what? Amplitude. Here what happens? In an elastic medium the frequency and the amplitude of an oscillation of each particle is the same. Here there is an molecules that will be oscillating, right? There is a disturbance occurring, means of what? There is a continuous of an oscillation will be taken place. That oscillation of a particle will be same at the of what? The amplitude and the frequency of an oscillation of each particle will be same. That is what we call as the one of the characteristic of an wave. And then the wave velocity is different from a particle velocity. Here we call as a particle velocity because of what reason? There is an oscillation of an particles will be taken place, right? That means there is a change in the velocity of an particle, and here we called the wave velocity, that is totally different from the wave velocity and the particle velocity. And then fifth one, the waves undergo a reflection, refraction, interference, diffraction, polarization and the absorption. Already we have to see in the properties or a phenomenon or a behavior of an waves. These are the characteristics of an of water, a wave. The energy of a wave is a partly kinetic and partially potential, and the total energy remains constant. What happens here? Both the kinetic and the potential energy will be partially, there are partly the kinetic and the sum of what? The potential. Because of that the total energy will be remains constant. These are the 6 characteristics of any the waves. What is that? Wavelength, and then of energy will be disturbance that can be moved forward but not the mass. And then here what happens? The frequency and the amplitude of the oscillation of each particle will be same, and then the velocity of the wave velocity is different from the particle velocity. Here there is a sum of the properties is also a characteristic of a wave. The energy of a wave is partially kinetic and partially potential. Because of that reason the total energy will be constant in the waves. These are all about of what? Characteristic of an waves. Now we move on to the topic of what? Oscillation. What is meant by oscillation? Oscillation refers to any periodic motion. What it refers to of what? Periodic motion. What is meant by periodic motion? Here there is an aim in the at a sum of a time that will be object will be oscillating, that is of what? That will be the motion will be repeating in of a such a time in a equilibrium position, that is called as of what? Periodic motion. And we have to be measured in a sum of a time, in a particular time that the object will be moving back and forth, that is of what we call the periodic motion. In that we have to be seen the oscillation refers to any periodic motion moving at a distance about an equilibrium position and repeat itself over and over a period of a time. What it means? The position will be equilibrium. Here we have to be taken the one example of any spring. What happens? It will be weighing the some weights. What happens here? There is any, after weighing the weight, it will be in a equilibrium position. Equilibrium position. What happens? Here we have to be stretched the string that will be moving in of water in a equilibrium position. There will be differences in the direction. Again it comes to the original place, that is of what we called, that is the oscillating, that will be oscillating in a, that will becomes and back to their original position, that we have to be called as the oscillation. What it means? Oscillation refers to a periodic motion moving at a distance, moving at some distance about the equilibrium position and repeat itself over and over for some periodic time t. Okay, that is called as of what? Oscillation. Now we have to be seen to the some of the criteria of selection of an oscillator. What are the criteria will be taken place for the selection of an oscillators? Here there is some criteria: the frequency range, how much of the range will be taken, and the occurrence, and dual resolution, and amplitude and frequency of stability, waveform distortion, and output of the impedance. These are the what the criteria for the selection of an oscillator. For the selection of an oscillator, we must require these 5 criteria: frequency range, occurrence, accuracy and dial resolution, amplitude and frequency stability, waveform distortion, and output impedance. These are the important criteria for the selection of an oscillator. Now we see of what in the oscillation: damped oscillation, and other one is the undamped oscillation. Now first we discuss what is the damped oscillation. In that way we have seen of what there is an same amplitude, maximum amplitude and the frequencies, right? But in the damped oscillations, what happens for wave, in the wave propagation at the starting, what happens? There is a maximum amplitude will be seen, but for the further propagation, what happens? The amplitude becomes the 0. There is no amplitude will be seen here. What happens? The amplitude becomes 0 in the oscillation. Amplitude becomes 0. That such a type of an oscillations are called as of what? Damped oscillation. Here we see this is of what? Amplitude, right? What happens from forwarding of an or further move of an waves or an oscillation? What happens? The amplitude becomes 0. Such a type of an oscillations are called as of what? The damped oscillations. Now move on to of what? Undamped oscillation. In this, what happens? The propagation of an wave or oscillating of an amplitude, what happens? That will be constant in the oscillation. Such type of oscillations are called as of what? Undamped oscillation. Here there is of what? The amplitude will be remains constant. Is it right? Such type of oscillations are called as of what? Undamped. Here what happens? Amplitude of oscillation remains constant. Such type of oscillations are called as of what? Undamped oscillations.